Good afternoon, everybody. I am the group leader I'm Stephanie Freeman, the group leader for the Clipion experiment that we'll be doing next week. My group members are Rebecca Goudry, Ty Gudros, and Ahmad Badawi. Okay. The objective of our experiment is to determine the latent heat of vaporization of water over a different range of temperatures and pressures using the Clipion equation, and then also verify the results that we get using the thermo steam tables. Alright, so here's the theory for our experiment. The Clipion equation says that the change in pressure, or the change in saturated pressure over the change in temperature is equal to the entropy over the specific volume, which is also equal to the latent heat of vaporization divided by the temperature multiplied by the specific volume. There's also this equation that I use to do hand calculations that you'll see later on. It's the ideal gas equation where it approximates the specific volume. Alright, so we have the apparatus for the experiment. We have this from the lab manual, and you can see on the apparatus it's numbered. So on 1, we have the 1,000 milliliter flask with a rubber stopper, and that's going to be on a hot plate. Then we have a thermocouple. It's a stainless steel type K thermocouple. And then 4 is the omega analog pressure transducer. 5 at the top there is the mechanical pressure gauge. 6 is the air bleed valve. 7 is the vacuum control valve. And then 8 is a centrifugal pump. 9 we have a water reservoir, and then 10 we have the computer system that we would use to log the data. So for the experimental procedure, we're going to turn the vacuum pump on, and then we're going to bring the flask to the lowest vacuum possible while leaving the vacuum valve open, or the vacuum control valve open. So then we're going to plug in the hot plate, and we're going to boil that. We're going to turn it on high setting, and our goal is to try to bring that water to boiling. Go back. Sorry. Then we're going to insert a thermocouple into the boiling water, but we don't want that thermocouple to touch the sides of the flask. We want it to be in the center of the flask, ideally. All right. Then, once the water starts to boil, we're going to start logging the data. And we'll close off the line to the vacuum pump, and we'll slowly cause the pressure to rise. Periodically, we'll check the values. This has valves, a little typo there. We're going to check the values that we are getting to see if they match the same values in the thermodynamic steam tables. Then we'll open the air bleed valve so the pressure can reach atmospheric pressure. Then we'll stop taking data whenever the water reaches a roll in the boiling, not a boiling point. That's also a typo, my bad. And then we'll turn off the hot plate and let the beaker cool off. Thank you. All right, so the shutdown procedure is fairly simple, but we got to make sure we do everything right. We're going to close the vacuum control and open the air bleed valve slowly. Turn off the pump. Make sure the heating plate is off. We're going to disconnect the 9-volt power supply, and then we're going to clean up the work area. Make sure we have all of our files saved from the computer. All right. So as a group leader, I had to make a plot of the pressure versus temperature for the saturated water tabulated values. So these are values that I've gotten straight from the tables in the back of the thermo book. So as you can see, that the pressure increases, or as pressure increases, so does temperature. All right, and also as team leader, I had to do some calculations using the Clipion equation to calculate the latent heat of vaporization. And I used the equation that I had showed on my previous slide, where I had used the specific entry, the entropy over the specific volume, and then I also used the temperature and the Rakin constant. The R constant for an ideal gas. And my calculations were like way off. So as you can see, the ones from the table were way different. So I'm not sure what I did there, but I did do the calculations wrong, or they weren't right. So, but yeah, does anybody have any questions? That's the end of my presentation.